So let me get this range for Jordan here. All right, so here's our multiplicity notes. So this first thing we're gonna do is just kind of define multiplicity. I did this with you kind of informally on Friday. So I'm gonna kind of here formally define multiplicity for you. So again, if you something you're more comfortable doing on DocHub, where you can just go and type this real quick, so you don't have to type all the other stuff, might be a good choice. So the number of times a given factor appears in the factored form of the equation of a polynomial is called the multiplicity. There's no reason you should misspell that word because it is written all over this paper here. Okay. So that's all it is. It's really a really basic concept, like far as a straight definition. It's just the number of times that that factor appears within the factored form of the polynomial. So when I give you the factored form of a polynomial, this should be a really easy task. Right? Here's the factored form of this polynomial. Here's the factored form of this polynomial, versus a problem like this that is not in factored form. Right? No parentheses. This would be our standard form of the polynomial versus the factored form. Okay? So if I'm already in the factor form, I want to identify the real zeros and the multiplicity. So basically what I want to do is look at each part of this factored form. And notice I'm not highlighting the exponents, okay? I'm not highlighting the exponents, I'm doing that on purpose. So the next thing I want you guys to notice is that this -4 does not have an x with it, okay? So that means it's not a 0, which means we're going to ignore it. Okay? So it's not -4x, it's just -4. 0 is a value of x that makes y equal 0. This doesn't have a value of x with it, then it's not going to affect my zeros. Okay? So remember what a 0 is, right? We just take that x plus 5, we set it equal to 0. So that means that x equals -5. Remember, most time we saw it was just a sign switch from what we see in the factored form to that's the 0, right? If I plugged in -5, it would make it equal to 0. And then it has a multiplicity. I'm just going to abbreviate that mult of 2. So x plus 5 squared, right? There's 2 x plus 5s, which means that there would be 2 -5s. Okay? That would be how many times it shows up. So there's the multiplicity. So then x minus 1 would equal 0. So x would equal +1. And that would have a multiplicity of, then you look at the exponents right there. Well, there's a 1 there. Right? If there's no exponent, it's a 1. So I would have an exponent of 1. And I'm sorry that these are the same number. It's a pain in the butt coincidence, because I don't want you guys to think that this has anything to do with that. The value of the 0 has nothing to do with how many there are. Okay? It's just purely that's the one there. Different 1. And then x plus 3 equals 0, so x equals -3. And that one has a multiplicity of 3. Again, this being a -3 and this being a +3 have nothing to do with each other, just coincidence. Okay? So I'm just looking at those exponents. Okay? Anything you guys want to talk about with that one? We'll do another one. Oops. So I'm going to highlight pieces of this. I'm not going to highlight their exponents. So x equals 0. Oh, that was easy. So x equals 0. How many times does 0 show up as an answer? Yep, right, Sam? 5. Yep. Multiplicity of 5, right? Okay. Then what's our next 0 going to be? -4, right, Aiden? Jubal, how many times? What's the multiplicity of -4? Jubal, you there? June, what's our multiplicity here for -4?
No.
2, yep. And then, just a second. So then this one, 2x minus 1 equals 0. So then we add 1 over. So 2x equals 1. Divide by 2, x equals 1/2. Right, so there's our third 0. Brian, what's our multiplicity here for 1/2? Caleb, what's our multiplicity here for 1/2?
1.
1, yeah. Okay. Why do we read as multiplicity? Okay, so the exponent tells us the multiplicity, Aiden. So multiplicity specifically defines how many times the 0 shows up within the factored form. So they're very closely connected. An exponent means something specific about repeated multiplication. This is specifically just talking about the number of times it shows up. So they are very connected, but they refer to very different things. I don't know if that helps or not. All right, so this next part, we're just going to draw some kind of really quick sketches. This is a big reason why I wanted you guys to be sketching those graphs that was on the last homework. Those 7 problems you did. On each one of those, I wanted you to sketch a graph. I really wanted you to start to get a sense of what the multiplicities look like without knowing that's what you were doing. Okay. What's it mean for it to have a multiplicity of 1? What's it mean? What does it look like when it has a multiplicity of 1? What does it look like when it has a multiplicity of 2? What's it look like when it has a multiplicity of 3? That's kind of the same thing that we just saw on the activity, right? What was going on with the 3 and the 5 and the 7, right? And the 9. What was going on with the 2 and the 4 and the 6 and 8? So trying to get a sense for the shapes. Okay, what does the graph look like? Well, we look at the equation. It's really easy to see what the multiplicity is. What if I'm looking at the graph? Can I see what the multiplicity is? Right? When I look at this thing, can I say, hey, that's got a multiplicity of wow. And this other one's got a multiplicity of meh. Okay, how do we tell? Okay. So there's going to be some real quick sketches. Just going to do a simple set of axes. And then down there, we're going to describe what the shapes are, essentially. That's what the description is all about. Okay. So here, I'm just kind of making up problems. Okay, these aren't coming from anywhere. So I'm just saying, what if our problem in factored form was x plus 3 and then x minus 2? Okay. So kind of like we just saw. Okay. So we should be able to see when we look at that, say, oh, okay, I have a 0 over here at -3. Right? There's an x-intercept at -3, and then there'd be another one over here at +2. And both of those would have a multiplicity of 1 because there's no exponents there. Okay? If we were to draw that graph, it would look like this. It would be a parabola. Okay? But what we really want to focus on is what's happening near those x-intercepts. And then down here somewhere, it would curve. Okay? But the part I'm trying to focus on right now is what's happening right here. Yeah. Oops. So multiplicity affects that space right there. That's it. Doesn't affect any of this. Doesn't affect any of this. It just affects what's happening right here. How many times that number shows up as an answer affects the shape of the graph right there. Okay? And with the multiplicity of 1, what we'll always see is that it's just like a straight pass through. Right? The curve just pretty much runs straight through there. Nothing really weird is going on. Okay? The graph is crossing the x-axis at that point. Nothing weird. Okay? That's with a multiplicity of 1. With any even set of factors, so like if I had something like x minus 1 squared. So that means my 0 is at, or my x-intercept is at positive 1. If I was going to graph that, that would look like that. So if our job is to describe what's happening here, what's the graph doing at that x-intercept? So generally, what I call this is a bounce. That's my word for it. Okay, or it can be like a turnaround. So you notice the graph will kind of bounce off the x-axis at that point. It will not go through the x-axis at all. It'll exactly hit 0 and then turn around and go the other way. So it looks like a bounce. Right? Just like if you bounce a ball off the ground, it doesn't go down into the ground a little bit and then back out. Right? It hits the ground and then turns it. And the ball may squish, but it doesn't go through the ground. Okay? So a neat even number is going to look like a bounce. I get rid of that. All right, play ahead of here. Okay. Now, what we saw with 2 compared to 4, 6, 8, 10, right? The higher that number got, the flatter, right? Between the two vertical lines, the flatter it kind of got. Parabola was nice and round there. And then as we got it lower and lower, or bigger and bigger numbers, it got flatter and flatter. But it was still a bounce. And I talked to you guys about it, how it's actually still curved. It's just a very, very flat curve. Right? But you guys don't really need to worry about that. Okay? And I'll tell you why in just a second. Last one. If we had something like x plus 2 cubed, if we graphed x plus 2 cubed, so that means the 0 would be over here at negative 2. Remember what those cubed ones looks like? They look like this. They're kind of S-shaped, but turned on their sides. Okay? And then when we went to the 5 and the 7 and the 9, they got flatter and flatter and flatter in the middle, but they're still that kind of same S shape. What I think of this when I see it, I think it looks like there's a twist in the graph. Or a flattening. But it's still passing through the point. Okay. So, it is related to the 1 because a 1 is a pass-through, where the 1 passes straight through the point. So the odd ones still pass through the point versus the even ones where they bounce off the point. But as they get close to the point, they twist and then they go back up. Right? Or they come up and they twist and then they keep going up. Right? It kind of turns sharp again. Or it kind of flattens for a second and then keeps going up. But again, it's always curved, just looks flatter than normal. Okay? So any odd bigger than 1 would do that. Just again, it gets accentuated the higher odd you get. You guys don't need to worry about 5s and 7s and 9s and 23s Okay, if you see a twist on a graph, it's a 3. Okay, we're only going to do 3s. If you see a bounce on a graph, it's a 2. We're only going to do 2s. So when you guys look at a graph, you have to identify multiplicity from the graph. All you have to worry about is 1, 2, and 3. Okay, there'll be no 4, 5, 6, 7, 8, 9, 10, 40, 12s. Okay, 1, 2, or 3. All right, telling the difference between a 5 and a 3 is really difficult. It's not what we're up to. Okay, so 1, 2, and 3. That's all you got to worry about. All right, but it's just about getting an idea of what's it going to look like. If I give you the graph, can you tell me how many times that answer shows up? You guys have already done part of this. I gave you guys graphs a while ago and told you, tell me the answers, and then you wrote the equations from it. Okay? Now I'm just saying, tell me the answers and how many times they show up. You don't have to write the equation. This was from the writing polynomials assignment, 2 assignments ago. You guys had to you had to look at the graph and tell me what the answers were and then turn that into an equation. This is much less work. Look at the x-intercepts because x-intercepts are zeros, right? Zeros are x-intercepts. Okay. So x equals -2, x equals 0, and x equals 3. All right, those are the 3 x-intercepts I see. What's the multiplicity of each? So this is where we now look at the shape. What's happening right here? Okay. What's it look like? Well, as I look at that, it's going straight through -2. Well, where did straight come from? Right? It came from a 1. That means -2 shows up in answer once. And then looking at 0, what's the multiplicity of 0? So it's bouncing. So that means it has to be some even number. But we're only going to do 2. We're not going to do 4, 6, 8. Okay. So bounce means 2. And then at 3, as I look at that, it's running straight through 3. So straight means 1. We have 4 answers to that problem. One of them is -2, 2 of them are 0, and 1 of them is 3. Okay. There's 4 answers to this problem. That means this is an x to the 4th. You guys see how I'm doing that? Yeah, this is what I was saying. You guys can do this on DocHub because it's not really doing any math. I have to see the picture though, and we just need to talk about the picture. Yeah, so 1 is straight through, 2 is a bounce, and then 3 is that like twist, flattening, right? But still going up, right? So as I look at the next graph, I have a x-intercept there, got an x-intercept here, got an x-intercept here. So I'm going to start by just identifying, okay, there's -1, there's +1. What's it look like the purple one is? Yeah, 2.5, right? It's pretty much 2.5. Okay. Fractions are fine, right? Nothing weird. Not going to give you like 2.17. You guys should be able to see a half pretty easily. Okay. So then Aiden, what's this look like compared to those 3 pictures above? Which of those 3 pictures does it look like? Does it look like the straight? Does it look like the bounce? Does it look like the twist? Yeah, twist. So then what's our multiplicity here? There you go. So again, it would be any odd number bigger than 1, but we're going to top out at 3. Okay, so that one's going to have a 3. Braylon, What about that one? What's it look like compared to the ones above?
I'm not really sure. I'm still trying to understand it.
Which of these three graphs does it look like? Does it look like a pass-through, straight pass-through? Does it look like a bounce? Or does it look like a twist?
It looks like the middle one, a bounce.
Okay, so it looks like a bounce. And so we said that a bounce was going to go with multiplicity of 2. Okay? So you're just going to see which one it is, and since it's a bounce, it's going to be a 2. All right? And then Tion, what about the last one? Straight, okay? So then what's our multiplicity there? Cool. You guys feel like if I give you a graph, you can do that? Tell me what the answers are and how many times they show up? All about the shape. Okay, it's just what's a 1 look like, what's a 2 look like, what's a 3 look like. That's the thing, is they all look like that, right? Every time we do that, it looks like that. So that's the kind of idea. And it's a pattern. Okay. I just want to start this real quick. I'll probably just finish it like after you guys leave, and then that way it's just on the video. But this is what we were doing, last week. So I just want to do it again. I noticed this problem is much bigger than the ones we were doing. I wanted to add in this multiplicity thing. I wanted to have like higher multiplicities than what we've been seeing. So, but it's not going to change anything like that. It's got a 6th power. We haven't seen one that big yet. It's not going to change any of our process. Right? We're still going to look at the 0 that we're being given, and we're going to take it out of the polynomial that we have using synthetic division. Okay? And so remember, the number one thing we got to watch out for when we do synthetic division is, are there gaps? Right? And I remember, Jarrett, you talked about this problem. It looked like that there was gaps at the end. Right? And I think I said I ended up making a mistake on that. And it turned out that it did matter, that there was things missing at the end. So it goes 6, 5, 4, 3, but there's no square term, and there's also no x to the first term. There's also no constant term. Okay? So there are lots of gaps here. So as I set up my box, or half box, I would have 3 zeros at the end of it. And remember that value I'm giving you, guys, just comes over to the left side. We don't switch the sign because I'm giving you the 0. First number drops down, I get -2. -2 times 2 is -4. You add, you get 1. 2 times 1 is 2. You add, you get 6. 2 times 6 is 12. You add, you get 0. 2 times 0 is 0. 0. 0. Remember that last number needs to be 0. There's your first little check, right? Things went well. We got 0 at the end. I gave you a 0. You get 0. Now this is a big problem, so we got a lot of little labeling to do. I think I'm going to show you guys one more thing after this and we'll be done. So just like half a minute more. There's our remainder. There's our constant. Okay? Our x squared, x cubed, x to the 4th, x to the 5th. Right? Kept getting bigger and bigger and bigger. And it should make sense that it got to that big because we had 6. We took 1 away. We better have 5 now. Started with 6. We're taking 1 away. We better have 5 now. I shouldn't have a 6 here again. That wouldn't make sense. So as I go to write that, -2x to the 5th plus 1x to the 4th plus 6x cubed. But everything else is a 0. I don't need to write those now. Well, the zeros don't matter as far as this part. So we set that equal to 0. Remember, at this point, we're supposed to factor this to solve this. Okay? We've never factored 5th power problems before. Okay? Remember, the thing we can do here, first type of factoring we're always supposed to do is GCF. right? And those all have a cube in them. And in fact, I'm going to take a negative x cubed out, because remember when we have the first term is negative, we take out a negative. That's going to leave me with 2x squared plus 1x plus 6. Then you guys are going to do your AC method here to finish this. Okay? All right, so our AC here is 12. We need factors of 12 that had to be 1. Oh, I made a mistake. Took out a negative x cubed. So those should be negatives. So that means our AC is negative 12. We need factors of negative 12 that had to be negative 1. So it'd be 3, negative 4. So we'd have 2x squared minus plus 3x minus 4x minus 6. Should still be in parentheses, and you still want to carry that negative x cubed down. Still equal to 0. Break that guy in half. That leaves me with, those both have an x in them, times 2x times positive 3. Negative 4 and negative 6 both have a negative 2 in them, times 2x times positive 3. It'll still be in parentheses. Still equal to 0. And so we end up with 2x plus 3's come together. X minus 2 comes together. And we still have our negative x cubed out there, still equals 0. So this is at the point where we're ready to solve now. We've finally done factoring. So we say that negative x equals 0. Well, still just x equals 0. And I'm just looking at the part without the exponent. Here, 2x plus 3 equals 0. 2x plus 3 equals 0. So subtract 3 over, so 2x equals negative 3. And then divide by 2, x equals negative 3 halves. And negative 2x minus 2 equals 0. Of course, x equals 2. So what do I see here? I see x equals 0, x equals 3 halves, negative 3 halves, x equals 2. What was my original factor? So my original factor is also 2. So now when I go back to look at the problem and look for multiplicity information, so that x was being cubed, which means that the multiplicity of that 0 is 3. The exponent on the 2x plus 3 is a 1. That has a multiplicity of 1. And then the exponent on the x minus 2 is 1, but we also have the original x equals 2. That means we have 2 x equals 2's. So something I can do real quick to see if that makes sense, or does that add up? 3 plus 1 plus 2 is 6. I have 6 answers there. 3 zeros, 1 negative 3 halves, and 2 2's. Well, how many answers was I supposed to have? I'm supposed to have 6 answers. Right? So the last thing you kind of do is see if your answer, if your problem makes sense. Do you have what it takes, right? Do you have too many? Do you not have enough? You're supposed to have 6. You better have 6 when you're done. So that's how we can deal with like a really big problem, right? And try to figure out what the zeros are, what the multiplicities of the zeros are. Hope that made sense. Let me know if you got questions about things. I'll see you.